thought for how spacecraft slow down. And you really have to ask yourself, are we landing in an area that has an atmosphere? If not, you definitely want to go with retropropulsion, where you use retro thrusters pointed down at the surface of the planet to slow yourself down as you're coming in. If you do have an atmosphere, that makes it a lot easier, as the atmosphere acts as kind of a giant brake as you slow down. So you have your missions like Apollo that used retropropulsion when we went to the moon. When you're able to use the atmosphere, you have your heat shield on the blunt end of your spacecraft coming into the atmosphere, and then the parachutes will come out and slow you down the rest of the way to provide that safe landing. Here at NASA, we're constantly developing new technologies to help with that entry, descent, and landing, or EDL. Some of the trick in entering atmosphere is when you do have it, but it's really thin. One of the technologies NASA is developing to handle those is called HIAD, Hypersonic Inflatable Aerodynamic Decelerator. The HIAD can come as a heat shield much like the blunt body heat shields of those older missions that were made out of ceramics or metals and were very hard. However, HIAD is a flexible woven system that compacts really small, so you're able to actually get a very small heat shield inside your rocket diameter. With HIAD, when the fairing comes off, the heat shield can then inflate and expand to a diameter much larger than your rocket. Therefore, you're able to bring in a much larger payload than you were before. So how do spacecraft slow down? You have retropropulsion, you've got your rigid aeroshells and parachutes, and coming soon, we've got these inflatable heat shields.